Dear participants, welcome to the SWAYAM course, and today's lecture is week 2, lecture number 3. Module name is Cardiovascular System, and today's topic is dynamics of cardiovascular system and blood pressure. So here we will discuss regarding the what are the blood vessels are there, and then what is called as a blood pressure. So myself, Dr. Mukesh Kumar Bharti, Assistant Professor in the Department of Veterinary Physiology, Biochemistry, Faculty of Veterinary and Animal Sciences, Banaras in the University. So let's see what are the things we will discuss in this topic. So in this topic, first we will discuss what is called as a hemodynamics. Hemodynamics means how the blood is flowing through a blood vessels. What are the dynamics are there means how it is flowing in the arteries and how it is flowing in the veins. Then we will see what are the different types of blood vessels, and there we will see in brief means little anatomy of the blood vessels. Then we will see how the blood is distributed in different vascular system. Then we will see what are the called as a blood flow. Then we will see what are the types of blood flow. Two types of blood flow is there. Then we will see what are the factors which determine the flow of blood. After that we will see what is called as a blood pressure. What are the methods to determine measure the blood pressure, and what are the factors which regulate the arterial blood pressure. So altogether these things in brief we will discuss today. So let us start with the topic dynamics of cardiovascular system. In that first we will see what is called as a hemodynamics. So before coming to this one means you all must have studied the physics where you have studied the dynamics. So dynamics literally means study of the motion. Dynamics means study of the motion. So here we are going to discuss about the hemodynamics. Hem means you all know hem means blood, and dynamics means its movement or the motion. So the movement or the motion of blood through the vessels is known as a hemodynamics. It is the study of movement of blood through the circulatory system. It helps in understanding the relationship between the blood flow, blood pressure, dimensions of the vascular bed, means how the vascular systems are distributed in different parts of the body. As we already know, the major function of the cardiovascular system is to pump the blood. Pump the blood means the heart is pumping the blood, but once it will pump, how it will go to the different parts of the body, how it will be distributed? It will distribute through the vessels. So that today we are going to know what are the vessels are there and what are the dynamics are there, means what are the factors is there which is responsible for their flow and how that blood reach to the different body parts. So that is the basic concept of hemodynamics. It is said that it is essential for maintenance of blood pressure and other physical factor within the blood vessels, so that the volume of blood supplied to the different parts of body is adequate. So if vascular system or their distribution will not be proper, then the adequate amount of blood will not supply to the concerned organ. So that's why the blood vessels play very important role in reaching out the blood to the different organ or the tissue. We will see what is called as a vascular system. Vascular system is a series of tubes or vessels that circulate blood around the body. The vessels or the tubes that circulate the blood around the body. There are mainly three types of vessel. One is called as arteries, another is called as veins, and third is called as capillaries. So arteries generally carries the blood away from the heart. Generally artery is carrying blood away from the heart, and normally arteries carries the oxygenated blood and veins carries the deoxygenated blood, but exception for this is the pulmonary veins and pulmonary artery, where we have discussed that pulmonary artery carries the deoxygenated blood to the lungs, and then the pulmonary veins carries the oxygenated blood to the heart. So exception is there only for the pulmonary artery. Other than that, generally artery carries the oxygenated blood and the veins carries the deoxygenated blood. Then in between arteries and veins, another means capillary bed is there, that is called as a capillaries, which is the smallest in diameter, that allow the exchange of material between the blood and the tissue fluid. So where the exchange actually takes place, whatever the materials are there in the blood, that will exchange with the body fluid only at the place at the capillary. So capillary, we know that capillary is very thin means wall structure, only endothelium is there. So that's why at capillary level the exchange of means material takes place between the blood and the tissue fluid. So these are the three important types of blood vessels. You will see the blood anatomy. If you see the grossly, the means arteries and vein are composed of three layers, also called as the tunics. So three layers is there: tunica interna, that is the innermost, then the tunica media, that is called as the middle one, and tunica externa, which is the outermost. So blood altogether, this blood vessels is made up of three layers: tunica interna, tunica media, and tunica externa. In this, capillary is the blood vessels which is made up of only single layer of endothelium, that is the single unit, that is called as only made up of tunica interna. It does not have the tunica media and tunica externa. It only have the tunica made up of only tunica interna. That is why I told that exchange is taking place at the level of the capillary. Now we will see what are the what is the volume of blood in different parts. So we will see that around 84% of the entire volume of blood will remain in a systemic circulation. Systemic circulation and pulmonary circulation already we have discussed. Systemic circulation means the blood which is distributed into the all body parts, that is called as a systemic circulation, and pulmonary circulation means the blood which is going from the heart to the lungs for oxygenation, and then after oxygenation it return to the heart, that is called as a pulmonary circulation. So the around 84% of the entire blood is found in the systemic circulation. In the systemic circulation also greater part of the blood is remain in the veins. Vein carrying around 55 to 65% of the blood. So major reservoir of the blood in the body is the vein, not the arteries. Arteries carries only 13% of the blood, and around 7% are present in the arteriole and the capillary. So altogether, if you will see in the systemic circulation division, we will find that around major part of the blood is contained in the veins. Then around 5 to 7% already we have discussed that it supplied to the heart, and then around 9% will remain in the pulmonary circulation. So this is the volume of blood that is distributed in the different parts of the body. Then now we will see what is called as a blood flow. Here the dynamics will come in play, that here we will understand how the blood is flowing through a vessels. So blood flow means simply means the quantity of blood that passes at a given point in a circulation in a given period of time. Means the amount of blood flowing through a given parts in a given period of time, that is called as a blood flow. The unit for blood flow is either it is milliliter per minute or liter per minute. So that is the unit for how to express the blood flow. Blood flow through a vessels is determined by two important factors. One is called as a pressure difference between the two end of a vessel, that is also called as a pressure gradient, and second is called as a impediment or the hindrance of blood flow through the vessels, that is called as a vascular resistance. So here you can understand diagram I have drawn. You can see here the one end of vessel to another end of vessel. So pressure will be means different here and pressure will be different here. So whatever the difference will be there, delta P here means P1 minus P2. Suppose P1 is here and P2 is here. So difference of the pressure is called as a delta P. So here that is the pressure difference of the blood vessels at the two end of a vessels, and second is the resistance provided by the arteries. If the blood vessels will be narrow, then resistance will be more. If blood vessels will be wider, the resistance will be less. So that is called as a hindrance or the impediments. So the flow of blood through vessels can be calculated by the following formula by the Ohm's law. You can see here F, here you can see F is equal to delta P by R. So, delta P is here the pressure difference and R is the resistance. So, you can from this formula you can see that flow is directly proportional to the pressure difference. So, whatever the pressure difference will be there, blood flow will be the directly proportional to that, and it is inversely proportional to the resistance. It means ki if resistance will be more, blood flow will be less, and if resistance will be less, blood flow will be more. So, this formula states that blood flow is directly proportional to the pressure difference and inversely proportional to the resistance. Now, we will see what are the types of blood flow. Generally, there are two types of blood flow is there. One is called as a streamline flow or laminar flow, and second is called as a turbulent flow. So, if the blood will flow in a one direction from one end to the another end, that is called as a laminar or the streamline flow. In single direction, they will flow in a single direction. So, that is called as a laminar or streamline flow. And second is called the turbulent flow. Turbulent flow means if there some kind of hindrance will be there in the blood vessels. So, blood will not flow in a single direction. So, some kind of means there will be direction change will be there in the flow of blood, then that is called as a turbulent flow. So, the streamline flow is a silent flow. Streamline flow occurs only at velocities up to a very critical level, whereas the turbulent flow will be noisy flow. Means it means say that if blood is flowing and if some kind of hindrance will be there, then you may experience some kind of noise. So, this streamline flow will not produce any kind of sound, it will be silent flow, whereas the turbulent flow is a noisy flow. Here are some of the differences there between the laminar and the turbulent flow of the blood. So, laminar flow is characterized by layer of fluid moving in a series with each layer having a different velocity. Here in case of the laminar flow, you will find that maximum velocity takes place at the center. Vm will be at the center, means maximum velocity, whereas the V0 means minimum velocity will takes place near the vessels. So, at the side it have a very less velocity, but in the center it have a maximum velocity. So, this is the characteristics of a laminar flow. Then in case of the turbulent flow, one important term is there, that is called as a Reynolds number, R-E-Y, and Reynolds number. Reynolds number is a dimensionless formula that is only occur during the turbulent flow. So, we are finding the turbulent flow only when they have the their value will be around 2000 to 3000, then only they can produce sufficient amount of sound. So, that is the difference between the laminar and the turbulent flow. Now, what are the factors which determine the flow of blood? The volume of blood is determined by 5 important factors. Which are the factors? One is called as the pressure gradient. Already we have discussed that if the pressure difference will be whatever it is there, it is directly proportional to the blood flow. Then resistance of the blood flow, if the resistance is inversely proportional to the blood flow. Then viscosity of blood, if viscosity is also inversely proportional, because if viscosity will be high, the blood flow will be less. If viscosity will be less, then blood flow will be high. So, this also inversely proportional to the blood flow. Then diameter of blood vessels, if vessels diameter will be more, the blood flow will be more. If vessels diameter will be less, the blood flow will be less. Then finally, the velocity of blood flow. So, these are the factors which determine how much amount of volume will be flow through a vessels, and this can be whatever the things I have told you just now. These are the factors. This you can correlate with a very important equations are there, that is called as a Poiseuille-Hagen equation. So, Poiseuille-Hagen equation says that Q is equal to delta P by pi r to the power 4, delta P pi r to the power 4 divided by 8 eta L. So, from this derivation, what Poiseuille-Hagen has given, from this equation you can see that the blood flow is directly proportional to the pressure difference, this is directly proportional to the radius, and is inversely proportional to the viscosity and length of the tube. So, you can see here Q denotes the flow of blood Delta P denotes the change in the pressure, R denotes the vessel radius, and L denotes the length of the vessels, and eta denotes the viscosity of blood. So, viscosity of blood is inversely related with the blood flow, whereas the radius varies directly with the blood flow. So, from this formula you can easily derive whatever the things you want to know, you can easily derive from whatever the dynamics you want to know, you can easily derive from this Poiseuille-Hagen equation. So, we will discuss a little about the resistance of blood flow, how it is, means already we have discussed that blood flow is inversely proportional, but one another equation is there where it says that resistance is equal to delta P by Q, means resistance inversely proportional to the flow. So, already we have discussed that whatever, if resistance will be more, resistance will be more, the blood flow will be less. Then another very important term is there, that is called as vascular compliances. Vascular compliances means ability of blood vessels wall to expand and contract passively with the change in the pressure. So, if some vessels have the ability to contract much, they have the more compliances, and those vessels which have ability to not to contract expand much, they have a less compliances. So, compliances means basically it is the measure of stretchability or ability to getting stretch. The arterial wall, you know that artery have very thick wall, so they do not stretch much, so they have a less compliances. So, artery wall mostly made up of collagen and elastin fiber has little compliances and will not expand easily, thus resist the flow of blood, and it is called as a resistance vessel. So, artery is mostly called as a resistance vessel because it provides most of the resistance to the blood flow, whereas the veins is made up of relatively less collagen and less elastin, and they have more capability to expand. So, that is also known as, that is why the venous system is known as a capacitance vessel. So, arterial system is known as a resistance vessel, whereas the venous system is known as a capacitance vessel. So, that is the concept of vascular compliances. Diameter of blood vessels already we have discussed. If the diameter will be less, the blood flow will be go with the high pressure. If diameter will be more, blood flow will be smooth. So, here the same thing is explained, how the diameter of blood vessels affect the blood flow. This is the cross section of the different blood vessels. You can see here the cross section of aorta, although its wall thickness is much more, but cross section area is not as we are expecting. Small arteries have 20 centimeter square, but you can find it here. The most prominent one is the capillaries. Capillaries have the highest cross section area, and capillary are the blood vessels in the body that have much more distribution, because earlier I told that this capillary help in the exchange of nutrients between the blood and the tissue fluid. So, it is distributed in much capacity compared to that of the artery and the veins, and because of the more distribution, this capillary have much higher cross sectional area compared to the other blood vessels. Then velocity of blood flow, volume of blood flow is directly proportional to the velocity of blood flow, and velocity of blood flow is the rate at which the blood flow through the particular region. It may mainly depend upon the diameter or the cross section area of the blood vessels. Mean velocity of the blood flow is the highest in the large artery and lowest in the capillaries because of the presence of the different diameter. So, that is the whatever the dynamics of the blood vessels are there, means how the blood flow is flowing in through the blood vessels, and how we can determine the the dynamics of the blood vessels. Now, we will discuss what is called as a blood pressure. So, blood pressure is you know that along with the temperature, respiration rate and pulse rate, this blood pressure is also one of the 4 main vital signs of the body. Vital signs of the body means this is a very essential parameters which must be recorded. So, these days blood pressure problem are very prominent in, especially in the pet animals. Pet animals have means because of the lifestyle, because of the means living standards, these animals are also getting this kind of problem. So they have a very high this blood pressure problem in the pet animal also. So that's why we'll discuss in brief about the what is called as a blood pressure. So blood pressure is the pressure of the circulating blood on the walls of the blood vessels. And here when we talk about the blood pressure, we are mostly considering the arterial blood pressure. We are not considering the venous blood pressure. We are mostly considering the arterial blood pressure, because we know that arterial blood pressure is much higher, because arterial wall are thick and they can resist the pressure. So that's why we are mostly considering the arterial blood pressure. It is the pressure in the large arteries of the systemic circulations, and blood pressure, you know that it is measured in millimeters of mercury. So mercury column, when we talk about the how we can measure this blood pressure, at that time we will see that it is measuring through the mercury column. So it is measured in millimeters of mercury, but kilopascals are also is a very standard unit for the measuring of the blood pressure. One important term is there, that is called as hypertension. Hypertension and hypotension. Hypertension means abnormally high blood pressure. If some person or some animal have abnormally high blood pressure, then that is called as a hypertension. And reverse of that, if they have the lower blood pressure, then that is called as a low arterial blood pressure. So it is earlier I have told, it is one of the 4 main vital signs of the body, along with the respiration rate, temperature and the pulse rate. So now concept of blood pressure. What is the concept of blood pressure? When we talk about the concept of blood pressure, it is said that it is the required amount of force exerted by the blood against unit area. If you remember the formula of pressure, pressure is said that it is a force per unit area. Pressure is equal to force per unit area, means how much amount of force is applying on the blood vessels against the unit area. So when say that pressure in a vessel is 50 mmHg, in terms of blood vessels, if we will measure it, suppose we are measuring the blood pressure and we are saying that a normal, just I am taking the example of a human being, we are saying that the normal blood pressure is 120 by 80. So 120 by 80 mmHg means what? The systolic blood pressure is 120 mmHg and diastolic is 80 mmHg. It means ki the pressure required to raise the column of mercury up to the 120 and the pressure required to raise the mercury of column for the 80. So that is the concept, means how much amount of pressure we are applying on a unit area. So that is called as a pressure. So here the same kind of concept is applying in the on the blood vessels also. That is the concept of blood pressure. So unlike the heart rate, blood pressure does not differ among the species. Heart rate we have seen just in the previous lecture, we have seen that heart rate was differing in the different animal species. Why it is so? Because of the difference in the cardiac cycle length. But unlike heart rate, blood pressure does not differ among the species based on the body weight, as most mammals fall within the same range. Most of the mammals have the same range of blood pressure. However, there is a positive relationship between the blood pressure and the height of the head above the heart level. So if height of the head will be much higher above the heart level, then the pressure will change. Just the best example is in case of the giraffe. Giraffe, you have seen that they have very long neck and their heart position is very far distance from the neck. So in that case, the blood which required to supply to the brain area taking much pressure to reach there. So that is the one of the basic difference, but altogether species wise it does not vary. But if the relationship of heart to the brain will be much higher, means neck length will be very high, then the blood pressure will vary. Resting blood pressure at heart level increases with the neck length from dog to cow to the giraffe, while the difference in blood pressure at brain level among these species are much less. Birds have blood pressure range higher than that of the mammals, possibly due to the buffer gravitational force in the flying birds. Birds have a higher blood pressure than that of a mammals. Blood pressure of the newborn animal is significantly lower than that of the adult in both birds and the mammals. So, in the newborn animal, blood pressure is lower compared to that of the adult. So, normally arterial blood pressure are of two types. One is called as the systolic pressure, means the maximum pressure is called as systolic pressure, that is 120 mm of Hg, and range is 110 to 140, and another is called as a diastolic pressure, which will be around 40 mm Hg and range will be 70 to 90 mm of Hg. Then another pressure is called as a pulse pressure. Pulse pressure is the difference between the systolic and the diastolic pressure. So, the difference between systolic and diastolic is called as a pulse pressure. Another pressure is called as a mean arterial pressure. It is the average of the arterial pressure measured over a period of time. So, if they will take the average of that one, then that give the mean arterial pressure. So, mean pressure is equal to the diastolic pressure plus 1/3 of the systolic pressure. So, whatever the pressure will be given to you, if you know this formula, you can easily calculate the mean pressure. These are the normal value of the arterial pressure in the various species. You can see here I just highlighted giraffe, it have a very high blood pressure 211 to 151 and is very less in case of the rat. So, species wise it is generally means common, but depend upon the length of the neck. Then how this blood pressure can be measured? There are two methods are there. One is called as a direct method, another is called as a indirect method. So, direct method is generally applied in case of the animals because this requires the incision. This requires the incision of the tracheal and they have to insert some kind of instrument, then only this can be measured. But this cannot perform in case of the human beings. So, direct method only we can perform in case of the animal. Then next is called as a indirect method. Indirect method used to measure the arterial pressure in the human as well as in case of the animal. So, this indirect method is applicable both in case of the human as well as in case of the animal. So, the apparatus which is used for measuring of blood pressure is called as a sphygmomanometer. Sphygmomanometer means the instrument which is required to measure the pressure in the blood vessels. So, that is called as a sphygmomanometer. You might have seen the sphygmomanometer, mercury column is there, then cuff is there, that is applied on the hand, and then with the help of a stethoscope we are checking this beat, and then with the help of mercury column we are measuring how much is the blood vessels. So, there are three methods to measure the blood pressure. One is called as a palpatory method, another is auscultatory method, and third is the oscillatory method. So, among the all three methods, auscultatory method is the best method to measure the arterial blood pressure, because here in auscultatory method we are using both the sphygmomanometer as well as we are using the stethoscope. So, in brief we will describe all the three methods. So, the palpatory method, what we are doing, we are just felting the arterial means radial pulse, just we are feeling the radial pulse, and then we are applying the cuff on the hand, and then we are raising the pressure. So, at the point when we are unable to feel the pulse, at that time we will stop and then we are releasing the pressures, and then again once the pressure will start coming, that will be the systolic pressure. But the disadvantage of knowing measuring this blood pressure through palpatory method is that here is that disadvantage that we cannot measure the diastolic pressure. So, only systolic pressure we can measure through this palpatory method. So, that is the disadvantage, we cannot use the palpatory method for measuring the arterial blood pressure. Second is called the auscultatory method. This is the best method to measure the arterial blood pressure. Generally, when we are going for checking of the blood pressure, the doctors or the clinician, they are mostly use this auscultatory. They are using the sphygmomanometer and they are using the stethoscope. So, they are applying the cuff over the arm and then applying the pressure, and they are applying the pressure at the highest level. Once the beat will stop coming and they cannot hear any kind of pulsation, then at that time they will stop it, and then slowly they will release the pressures. Once the beat again will start coming, then very important term is there, that is called as a Kortkoff sound. This sound once start coming while decreasing the pressure, that is called as a systolic pressure, means highest pressure. Then again they have to lower the pressure and once the sound, that Korotkoff sound which started at the systolic pressure, once that sound will be disappear at the point that is called as a diastolic pressure. So, that is why this method is very accurate to determine the systolic pressure as well as the diastolic pressure. So, this method is very important one. Third is called as a oscillatory method. Oscillatory method is also like a auscultatory method only, but here difference is there that two types of Korotkoff sound we are not hearing in the oscillatory method. Here we are just observing the column of the mercury. Once the pulsation will start, we have to see the column of the mercury, and at what fluctuation, at what oscillation it is going up and down, that we have to see. So, one will be when the oscillation will be starting, that is called as a systolic, and once the oscillation will disappear, that is called as a diastolic. So, that is but among three only the auscultatory method is best method to measure the blood pressures. Now, how it can be regulated? Regulation of the arterial blood pressure. Arterial blood pressure can be regulated by 4 regulatory mechanism. One is called as a nervous mechanism, or also called as a short term regulatory mechanism. It can be done by the vasomotor center, or it can be done by the certain receptors are there like baroreceptors, means pressure receptor, and also through the chemoreceptors. So, this is called as a nervous regulation of this means blood pressure. Then second is called as a renal regulation, is also called as a long term regulation, means whatever the blood pressure will be low or high, it can be regulated by the kidney. If blood pressure will be less, this can be maintained by the RAS mechanism, renin, angiotensin, aldosterone system. Then third is called as a hormonal mechanism. Certain hormones are there that causes the vasoconstriction like noradrenaline, aldosterone, antidiuretic hormone, angiotensin and serotonin. These causes the vasoconstriction, means they help in the raising of the blood pressure. Another hormone, some hormones are there that is called as vasodilation, means the hormones are bradykinin, atrial natriuretic peptide, prostaglandins, histamines and brain natriuretic peptide. So, this causes the vasodilation. So, it means it help in the releasing of the blood pressure. Now, other factors are the local mechanism are there like local vasoconstrictor, EDCF, endothelins are called as a vasoconstrictor, whereas the carbon dioxide, lactate, hydrogen ion and nitric oxide, these are called as a vasodilator. So, by these 4 mechanisms we can regulate the arterial blood pressure. For this only we have described certain things like how nervous regulation will takes place through the and mechanism of the action for the vasomotor center. Here the role of baroreceptor and the chemoreceptor will takes place. So, baroreceptors are mostly present in the carotid body and the aortic arc, whereas the chemoreceptors are present in the carotid and aortic body. So, chemoreceptors mainly sense the chemical changes, where the baroreceptors will change the pressure. So, when the blood is flowing, that pressure will be sensed by these baroreceptors and will send the information to the brain, and from there the concerned changes will takes place. Long term regulation already we have discussed, it will takes place through the kidney. So, that RAS mechanism. So, in this way we have discussed in this class that how the blood pressure can be, what is the blood pressure, and before that we have discussed the dynamics of cardiovascular system, means whatever the blood is flowing, how it is flowing, what are the factors which determine the flow of blood, and then we have seen that what is called as the blood pressure, how the blood pressure can be measured, what are the method to measure blood pressure, and then we have seen what are the factors which regulate the blood pressure. That is the end of class. Thank you.